Hi, this is the demo for a CI pipeline for a small calculator app. We'll quickly go over the first three milestones before we start explaining the fourth milestone that we have done. For the first milestone, what we did was we configured a post commit hook so that it triggers a build on Jenkins. I'll just quickly show you how that works. Now the build has been triggered, and as you can see over here, a new build has started, and it takes a while before it completes. So I'll just pause it for a while, pause it for a second, and resume it as soon as the build finishes. So here you can see the build has passed, and the console output. In the console output, we can see all the dependencies has were installed, and in the end, the build was a success. And if you go back to the dashboard, we can see check style was used to do the testing. This check style graph shows us the trend of how the design errors were there in uh, the traditional JavaScript file. Now I'll show you how the testing has been done. So for testing we've used Mocha.js, and I'll just run. It's just a small file to test the basic functions that we have written. So as you can see, all the test cases have passed. Apart from this, we've also used Istanbul.js for showing the test coverage, and this is the test file that we have created for that has been generated automatically using Istanbul.js. Now moving on to the milestone 3, I'll pause it for a second and we'll continue in a while.
Moving on to milestone 3. In our milestone 3, we have done deployment on the production and canary server. So, what our current milestone does is whenever there's a commit, so it does a build on the Jenkins server, and whenever after it's a success, it then launches four new instances. One is a production, one is a canary, one is a Redis instance, and one is a proxy instance. And so uh, these and it deploys the code on the production and the canary server, and it starts our application on those two instances, and it also starts a proxy server on the proxy instance, which routes traffic between these two servers with 75% to 25% ratio. And then there's also Redis server, which maintains the database of the list of currently present servers. And we have also implemented auto scale such that whenever the load is more, an alert is raised, and the proxy server takes care of also the auto scaling part, where it creates a new instance, and the entry of that instance is added in the Redis server. So let us start a build right now. So So I've started a build, and it will check for success, and after that it would start deploying. As we can see, our build has been successful, and after that it starts creating new Amazon instances. To see them created dynamically, we can visit our Amazon website. These are the still instances which have been terminated. This is our Jenkins instance, and if we refresh it, we would see new running instances over here. So they are our production canary, and two more have to come up, which is the proxy and the Redis. Three have come up so far. So after the instances got created, an Ansible playbook was called, which installs all the packages on our proxy and the production canary and the Redis instances, and it installs all the packages on them, copies the does a deployment, and starts our app on the production and the canary server, and the proxy server on the proxy instance, as well as the Redis server on the Redis instance. So all this is done by a single Ansible playbook, and that Ansible playbook is seen to be running right now. This will take a few seconds, so I'll pause the video until this finishes. So now, as the Ansible script has completed deploying all the code in the production and the canary and started all the servers, so now we would visit our proxy server and we would see our app running on it. So let's go to our proxy server. So this is our app. It just for now it does addition and multiplication. We see it from the production server, and if we give a certain set of numbers and we say add, it says a sum. Similarly for the product too. So we have also implemented feature flags. The feature flag would add another subtraction button over here. So for this, currently it is just manual. We would see in our future special deployment states that we make it automated. So we would just log into our Redis CLI, and if we set the subtraction feature flag to true, and now if we refresh this page, we see that we get a subtract flag over here. So this would also be functional, and we see, so no matter how many times we refresh, you still have the subtract flag. You can again toggle it back to false, and now if we refresh, this would disappear. So this is how we implemented feature flags. Now I would show you how we implemented auto scaling. So for auto scale, what we do is the production server raises an alarm which sends a get request to the proxy server, and then the proxy server creates a new instance for us. So currently we have 1, 2, 3, 4 and 5 running instances, and we would see when an auto scale occurs, a fifth instance would come up, and that would be also deployed with our particular app. So when we create an alert, now we would notice that a new instance is being created. You just need to refresh this a few times. As we notice, we get a new instance here which is currently initializing, and after that gets properly initialized, an Ansible script would run which would provision that particular server in the same way as our production and canary server were built. So this is how we implemented auto scaling in our deployment milestone. Now moving on to our final milestone, the special milestone, we have implemented something called as a parser bot. So that gives us a clean CLI in which we can enter user-friendly commands to enable or disable features, and also create and destroy instances. So we implemented this so that a developer can implement all such functionalities with ease. So let's run our parser CLI. So currently we are in our parser CLI. So this is our parser CLI. So first I would like to show you the enabling of features. So currently if you notice, the subtract feature on our web page is off, and what we would do is we would enable our subtract feature from here. So by hitting enable subtract, the subtract feature gets enabled, and if we refresh this again, we see that our subtract feature has been enabled. We can disable this feature too, and we refresh it, we see that the feature has disappeared. So this is how we any developer can easily enable and disable the features using the CLI. Next, I would like to show you how we are creating instances. So currently on our Amazon Web Services, we have 1, 2, 3, 4, 5, 6 running instances, and we would see that whenever we hit spawn instance, a new instance would spawn for us, and that could be noted if we refresh the page over here. As you can see, a new instance currently being spawned, and it's in an initializing state. So by using this command, a developer can easily spawn a new instance whenever needed. So if we visit our web page, we would see the new instance is created, and we can also destroy an instance with our CLI. So currently we have a certain number of instances running. If we hit destroy instance, it says the instance with this particular IP is being set for termination. So if we visit our web browser 54.2.18.49, so it is this particular. So let us reload this. So as you see, this particular instance is shutting down. The ID is 084C1, the same ID which was trying to be destroyed over here. This instance is being shut down, and this is how we can even destroy instances. Uh, Apart from this demo, we in the future, for the final submission, we are also planning to introduce few more features for our CLI. Currently, these are the 4 features which are present in our parser bot. Next, we will be moving on to our additional functionality which we have added to our pipeline.
So along with the CLI bot, parser bot, what we realized throughout the project was it was really difficult to keep track of all your builds, and if you actually run a build, you don't really come to know that the build is. I mean, everyone doesn't come to know that the build is somebody has started a build. So we wanted something so that we could keep track of all our builds without actually getting to Jenkins, because you have to remember the IP of Jenkins. So what we did was we used this service called Zapier, and we configured it with both Google Sheets and Slack. So whenever now we run a build, we get a message on Slack, and whenever a build is triggered, it also adds into a Google Sheet document that the build is run, and all the details of the build is also stored. So I'll just show it to you. I don't really have to make a commit, I just need a build to be running. So I'll just make a build from here now, and see, so this is a message that I got from Slack. I can show it to you on Slack. So this is the latest build, then build number 40, and as you can see, this is the latest build that has been triggered, and it gives you all the details, like the name of the project, and the link directly to the build, so that everyone can directly go and see if the build is failing or passing. As well as this is the Google Sheets, and as you can see, this is the build number, and like I can store the build number, the status, the build URL, what phase the build is in, the commit which triggered the build, and the branch of the build. And this is the latest one. So this is build number 40, and it's a success. As you can see here, the build is a success. That's what has been stored. And initially when the build has started, we do not know the status of the build, so we don't have anything in this column right here. But then when the build was completed and finalized, we know the status of the build. So there it is. and this is the commit that was that on which the build which triggered the build and the branch of the build. Yeah, so this actually helps us a lot to keep track of all our builds without actually having to go back to Jenkins and check. So that's pretty much it from our side. Thank you.